It's now about 18 months since the idea for this product, the EGON DC-Hub, was mooted, and 1 year of testing is now complete.
We are now putting 130 amps through.
And we are now launching it onto the market. So here it is here. We called it the DC-Hub. It's a center where all of the components in a DC installation, whether it be in a four-wheel drive, a camper caravan, a boat, whatever, all come together in one place. And I would like to now explain to you why this product is unique. And I don't use the word unique lightly. There is no other product like this on the face of the earth as far as we know. We haven't built a version of something else. We have designed, developed, tested, and built a unique problem-solving product. What problem does it solve? All right, that would be jumping the gun a little bit. The idea of it started when I was building a vehicle for a client, and this was late 2018. Principal electrical equipment that needs to be run in the vehicle. This one is a fairly simple one. And I had brought in Heiner Klarman, who I saw his work as an auto, and not so much an auto electrician, but an auto electrician engineer. He was designing and developing fitments for four-wheel drives, caravan, campers, and things like that. And he was doing superb work. Yes.
As soon as you go to cheap components, you go to cheap circuit breakers, all that
Yes.
sort of stuff, you get voltage drop,
Yes.
you get nasties in it. So it always pays in the long run to pay a little bit more on your accessories.
And so I commissioned him to build a setup for my client, and he did a beautiful job. Means that we have not had to cut a single wire in this entire vehicle that was put in by the manufacturer. And I said to him once he had put it in there, and I said, you know, there's only one thing wrong with this, is what happens if what are we going to do with the next one? Are we going to do the same thing again? Is there a way of creating that electrical fitment box unit and replicate it, so that when I ask you to build another one for me, it doesn't cost me quite as much, because you're not going to be putting in quite so much developmental time as you have already done on this one. And he said to me, well, I've had an idea to actually do something like that myself. Do you think it would be marketable? And my answer was, no question that it would be marketable. So we sat and we realized that, in fact, we were coming up with some quite unique, fresh concepts. Now, the purpose of the DC-Hub is to have one central place with integral fuse box where everything is wired to, including the auxiliary batteries, main batteries, charging units, lights, you name it, all come together in one place. The idea is that if all the cables go to one place, it reduces the amount of cable runs, it simplifies the build enormously, because what you do, you don't start with the fuse box and run cables. You do it the other way around. You put the lights, you put the fridge, you put your little oven, you put your compressor, you put all of the little bits and pieces, the hot water boiler, whatever, all your little bits and pieces that are drawing current from your auxiliary battery in place, and you run all of the cables to a central point where they get plugged into here. And the beauty of this, doing it that way, is that the amount of time saved in the actual build, the process of running wires and the process of wiring, is reduced considerably. It's also reduced because this does not require lugs. It does not require, so it doesn't require the crimping of lugs. It doesn't even require heat shrinking the cables, because each of these connectors, and they are very high quality connections, we went for the best because we wanted to save the user money. And I said to Heiner, can we make this foolproof? And the reason for that is that One of the big problems in the caravan four-wheel drive industry is quality control. A lot of these people do beautiful work, and it's let down by poor electrical, because the electrical, to do it well, is expensive, because it does require expertise. And a lot of workshops will say, well, you know, it's good enough, we know how to do some wiring, we know how to run wires. And sometimes they think they know how to run wires, and they just plain don't, and the quality is very poor. So they'll work for a while, and then the clients out in the bush somewhere have electrical failures purely because they've used the wrong size cables, bad lugs, the wrong kind of lugs, voltage drops across the system, and failures. There is expertise needed to do that well. And guys, here it is. We have, as part of this process of can we make it foolproof, taken away almost all of the expertise needed to wire up a build, and quite a complex build at that. You just run the wires. All you've got to know is how thick should the wires be to carry the current so that there's no voltage drop, because it's all about voltage drop across cables. When you have a connection, you have a voltage drop. It's science. That's what happens. Okay, so even in the instruction booklets that we supply with it, there are guides not only to how to wire it, but also guides on what kind of cables, thickness of cables, length of cables, etc. So you follow that, you use this as the center, and we've done all of the difficult work, all of it. And the voltage drop through this thing is really low. We've got a maximum of 60 amps, and what are we going to crank it up to?
First, we're going to leave it on 60 amps for a while to see if anything heats up, so we test it to its specification.
Right.
And at the moment, obviously, we're not charging, we're drawing current, but
we just want current flow. It doesn't matter.
That's right, it doesn't matter
which
way around. We just want to see what the temperatures are doing.
Yes.
So we're going to leave it on 60 for a while, or as close as possible to 60, see what the temperatures are doing on the circuit board, on the fuse holders, on the connectors. And once we establish that we reach an equilibrium there, somewhere in the temperature, we then later on going to crank it slightly up to see at what point the fuse blows.
And if anything else gets hot before the point where it blows.
That's exactly right.
Okay.
The fuse is bubbling. I can see, there we go, 145, and the fuse blows exactly where it should be.
So what does that actually prove?
That proves that our fuse holder, our circuit board, our connector, they are actually standing up to what they should be. We've got an 80 amp fuse in here, and we put 100 amp through that circuit, and the 100 amp should not blow the fuse straight away. It should slowly heat up the fuse up to 145 degrees, and then the fuse will pop. And the fuse has to go before anything else in the circuit goes, and we just proved that.
Also during these tests we need to work out what the voltage drop is in the board itself, because more higher the voltage drop, higher the temperature, the less efficient the unit is.
We're now getting 600 millivolt voltage drop from the battery terminal to the inverter terminal at 65 amps that we are drawing at the moment, but we are also using cables that are too small for what we're doing at the moment. So the results are really good like that. We've massively reduced voltage drop from normal installations. The peak of what this fuse should be able to cope with, 65 amps constantly.
It's blown, yes?
Yeah, it just blew, so that is good. The circuit is well protected.
Because that's the problem with poor quality electrical fitting. Voltage drop causes all kinds of things, poor charging, poor performance, lots of problems. So if we can get rid of that question mark, voltage drop question mark, we can solve that problem. That's the first problem solved. Second problem that we would be able to overcome is that if somebody could take this and actually, having really not done any wiring at all, with some basic instructions, I mean, you know how to strip the plastic off a wire. Well, if you know where to put it, you put it in and you tighten it. There's nothing to go wrong. As long as you put it in properly and tighten it properly, that's all you've got to know how to do. The rest of it is, we remove the chances of failure because we've kept it simple. We've dumbed it down so that anybody, I mean, I know looking at that looks like quite complicated. It is just, it's so not. It is so not complicated. What it is versatile. So all the charging systems, the main battery comes in here, the auxiliary battery, what's the auxiliary battery? Car battery comes in here. Your DC to DC charger, the way that you're going to charge your auxiliary battery, this battery that's connected here, comes in here. So all your DC to DC get plugged in here. You want solar? Plug it in here. Just plug it straight in. Do an Anderson plug somewhere where it's easy to access from outside the vehicle and plug it in there. It's wired, so it goes via the DC to DC. If your DC to DC charger doesn't have its own solar capacity, well then don't plug it in there, plug it in there. That one's regulated, that one's unregulated. You have to have a regulator to regulate solar input. We tested this, and the other question was, how much current could it take? If somebody abused it, what would happen?
Now we are gonna overload the circuits. We are now testing the circuit that is responsible for charging the batteries from the DC-DC charger, which should have a maximum of 60 amps. And we put a 100 amp fuse in there and put continuously 100 amps through it and see how the circuit board behaves, if it can cope with it or not.
And we thought, okay, if somebody abused it, how hot could this thing get before it starts to malfunction? Well, we spent a day making a lot of smoke. We just blew fuses and then we jammed bits of wire into these various connections. So how many amps are you going to pump through it?
Now we are at 100.
And ran very high currents using a 2 kilowatt inverter going flat out.
But I'm going to dial it up a bit now.
You would never wire a 2 kilowatt inverter through this. Inverters need to go straight to the battery. They just do. It's one of the few things that you wouldn't wire through here. Well, we thought, well, let's wire it through there and see what happens.
Let's see. 150 amps is probably the maximum the inverter can take.
The inverter's screaming.
Now we are drawing more than twice what we should be through the charge connector. We are at 110 degrees now at the connector.
How long do we do it for to simulate?
Let's see how long it takes to break it. Now it is the cable itself. So the circuit board is okay, but the big jumper cable I put in there is melting at the moment. It is running a 2000 watt inverter at its limits at the moment, and all that's giving in is the cable itself. If you want to double check, Andrew, we are running about 130 amps through it.
How's the board taking it?
The board is at 110 degrees roughly, getting less here.
Eventually we did get some damage.
Andrew, I really want to destroy this, but let's see if we can pump a little bit more through it.
So I want to point out to you though that I know we're breaking a lot of rules here. For example, we should not be using cables that thin for a 2000 watt inverter. We're doing it on purpose because these points of connections here will only allow us to put in cable that thick. And the reason for that is that we don't want people putting heavier cables in because then they might damage something. But it's turned out that even, I mean, I can hardly touch that. That is very, very warm. Yeah, that's very, very warm. That was the point of the reason why we put in cables that were too thin. We did it on purpose to try and stretch the design parameters to their absolute maximum. So that was a part of the thing. Can we make it foolproof? If somebody really just didn't read the instructions and just was really stupid, what would happen? Well, the fuse would blow. The fuse would blow. The fuse would blow. That's the worst that could happen. The other part of it was that because we wanted to produce it and make it viable as a product, how much time would this really save if somebody was building something. Heine does these builds a lot, and he's now, this is his go-to product now when he's doing a build. That's it. There's no question. He says to me, it's a no-brainer. On a medium to reasonably complex build, this item will save him at least, or his people, at least 7 hours of labor. Plus the cost of all the lugs, all the shrink, and fuse box, because it's integral. And warranty claims into the future. You'll notice quite a few holes for mounting.
Once all the screws are in, you have to firmly tighten the screws to make sure they will not come loose over time.
All right, now the reason for those holes is that we figured that you might want to mount it this way or this way or this way, whatever. Okay, versatility. And when we developed this, it's a stainless steel mounting box. And it's got some interesting design features.
These holes in your DC-Hub bracket are made for cable ties.
One of the needs for using shrink wrap in a connector is it reduces vibration. So you have a connector on the end of a cable and you have vibration, and it reduces that vibration.
The cable tie itself will hold the cable down and prevent any rattling on the contact.
One of the most important functions of a AC distribution board is, of course, diagnostics. You have an overload circuit, you have an earth leakage, this switch will trip, and you can immediately see the switch is down, and that is the faulty circuit. With DC-Hub, it's a similar thing, except it isn't a dropped switch, it's a small LED that illuminates when a fuse blows.
Looking at the board, you will notice that every fuse has got a LED connector to it. Once you connect the circuit, you will find that your LED will turn on if it is possible that a current will run through the circuit. Put a fuse in, like this, and you will find the LED turns off. The LED is an indication for a blown fuse. So should this fuse blow, your LED light will come back on to indicate that there's a problem with the fault.
So then, once you've run all the cables to this, and again you can see the mounting box here is got lots of holes behind it, lots of holes. You can mount it any way you like. Lots of mounting options. This doesn't come with it, this is sold separately. And also has a clear perspex top, which fits like that. So once inside, it's very easy to do a diagnostic because you can see. And then 5 Allen keys, that comes off, and then you can go and change the fuse or correct any issues or add cables if you're adding accessories to the build. We have created a YouTube channel with instructions for mounting, instructions for wiring, different types of DC to DC chargers, you name it. We put a whole lot of videos up explaining the best process of how to wire the DC-Hub. They are available from egon.com.au. They are not yet available in any other country apart from Australia, but they will be soon. We are hoping to get them in both South Africa by the middle of 2021 and likewise in North America. But we can send you them directly from our distribution center in Australia, Western Australia. So they are available for ordering right now. This is a game changer. And I have been trying to find a similar product for almost a year on the internet. I found some similar, I found some products that kind of go halfway, but they don't go all the way. They're not nearly as versatile as this. And I don't believe that they will take the punishment of this, the way it's designed. And it's when planning now, and we've been doing now a lot of builds, the electrical system, that's the heart of the electrical system. That it's a no-brainer because it simplifies, it mentally simplifies a complex build fantastically, because now everything comes to the same place. Everything, one place. It really is magic. And the challenge with it being a product that has no peer, there is no matching product, is to try and explain to people, hey, somebody has got to be the first to design a product to do a certain job. Well, this is one of those products. So to try and get me to get people to understand what this is quite a challenge. But it's unlike anything, you know, it's not, oh, I'll go another route. Well, sure. Will your other route be as simple as this? No, it cannot be. Not possible. Not possible. In fact, we've got to the stage now where this is working so well. The build we've recently done, we started piping up a water system. And it was me to Heino, or Heino to me, and we said, what are we doing? We need one of these for water. The water comes in, the water goes out. And in this box, everything is handled. The switching of the water, the solenoid pumps, if you want hot water, if you want cold water, if you want pressurized water, one box, you can have hot water in, you can have cold water in, you can have hot water out, you can have cold water in. If you have water coming in, you want it from a number of choices, because maybe you've got 2 tanks. Maybe you've got a tank and a grey tank, or maybe you want to suck water out of a bucket because you want to wash your dishes from the river water, and you hoik up a bucket of river water and you just drop up and you go click, I'll have that water, thank you very much, and it pumps it through. Nobody's done this. We have, and I'm thinking that it's now January. I'm thinking that we will be able to launch that product. It's in testing now. Within 6 months, we will have that product tested and ready to go. And that again dumbs down a water installation. All the pipes go to one place and out they come with a simple switching device, and not only that, a temperature control device, because you know how many water heaters and how difficult it is on most of them to get the water to exactly the right temperature. Solved. Doesn't matter what temperature comes in, you set what temperature you want to come out, and guess what? The water that comes out is exactly that temperature, because if it's not that temperature, it doesn't come out. It mixes it perfectly and out it comes. That's all part of the system. It's brilliant, and hopefully within 2 or 3 months I'm going to be able to bring you another video like this one about our water hub. Thank you for indulging me. It was the best thing actually about 2020.